Okay, hello, welcome to a new semester. So my name is Jürgen Pfeffer. I am trying to teach you some programming skills here. And yeah, let me start by saying a couple of random things. And so first of all, yes, you do not need to be here. Yeah? So I do realize that the moment I say this, 2/3 of you will not come next week. I'm fine with that, okay? I mean, I wouldn't say I don't care if you're here or not, but I don't care. But I know it's not a nice thing to say about students. But there are 10 or 20 students in your group who actually like to be in classrooms. And so I am happy if you guys show up and interact with me, and especially we will use the lectures to maybe more in depth talk about some topics, and but all the content covered that is necessary, and also the content is necessary for the exercises, will be on videos on YouTube. Okay, so on YouTube you will have these little 10-15 minutes videos describing the concept, showing things. And if you work through these things interactively, because I've learned in the past years that, especially when you learn, like, I don't know, programming or also some methods or so, different people have different speeds, and so it makes a lot of sense to have like a video where you can stop and go in your tempo. So what I would suggest is that you do look into these videos. We will not upload them all at once, because maybe we do upload them in advance. So because sometimes, especially in the beginning of the semester, you often have more time than later. But there will be about like 4 exercises over the semester, and we will tell you how many videos you will need to basically work through for every exercise. So you can do the entire class without ever showing up here, and also actually, I mean, technically you wouldn't even need to watch the videos from the classes, because everything you need to know is in the videos that describe the content. Okay, I think it makes sense to show up here or to also watch the videos from the classes, because in the content videos, I follow a certain logic on a compartmentalized logic and on different aspects of programming. And here we often talk a little bit more big picture. So it makes sense to have these additional infos. But it might be not good enough to only show up here. So you also need to look at these other videos. But they're not a lot, don't worry. Does it make sense? Okay. The other thing is, this class originally was in Germany a couple of years ago. And in the meantime, we have translated all the slides, but I just realized that I forgot to translate the introduction slides. So there will be a couple of German slides here in the next couple of minutes. Don't worry. I just use them as a reminder for myself to know which topics to talk about. Okay, there's no need to read them or to translate them. You can just ignore them. For the videos that we will do here, I'll just double check if everything looks like real. Looks good. So for the videos that we do here is, I will not have a camera here. So you are not filmed, I'm not filmed. I mean, it's not that I don't think that I'm not worth filming, but my experience is from a couple of Corona years that cameras are shitty anyway, and the only thing you really care is the voice. And so I'm recording what I speak in a pretty good quality, and we record the screen, and I think everything else is not very important that happens. Okay, so that's the recording strategy. Yeah, so yes, this is a class for, I mean, I know we're a technical university, but we realize that there are a lot of people here who are not coding their entire life. So you guys in the room here, you had a happy childhood, a happy youth. You had friends. You spent a lot of time outside. Okay, you had a lot of fun during your teenage years. as a side effect, you're not able to program. And what we do here is try to fix this. Okay, so now you don't need to think, so that after this class you maybe don't need to think all the time, oh, maybe I should have went to a coding club in high school and not to I don't know, flamenco. Yeah, so flamenco is fine. Now you're a much cooler person than those nerds in the coding class, but now we'll like try to fix the gap a little bit in the other dimension as well. Okay, because those nerds will never learn how to do flamenco. Okay, but you can. So now, yeah, you know what I mean. So so this class is really for so I do not expect you to know anything about coding. I'm aware that there are two chemists in the room who have coded in some ancient language, and now they want to learn real coding. It's fine, you can stay here as well, but shut up when I ask a question, okay? Because every time you say something way too smart, the rest of the class is very intimidated because they have no fucking clue what we're talking about, okay? So if you have experience, you're fine, you can stay. But yeah, be aware that the class is really for people with no experience, okay? So yes. So we assume that you have never coded anything, which makes it, especially at the beginning, very slow. Okay, so before we even start to write a single line of code, I spent quite some time talking about how to think to think in a way that a computer can understand you. Yeah. And so because the algorithm, and we will talk about this later, for those of you who sit behind this thing, there are better seats as well. So it's okay to hide if you want. Because when we talk about algorithm, when we talk about coding, 90% of the work is actually to deconstruct the problem in ways that a computer can understand it. So this is actually what we mostly learn about. And only 10 or 20% is then how to operationalize this with like 20 or 30 vocabularies and how to write the actual code. But you need to, in order to conceptualize how the program works, we need to first start to learn a little bit to think like a computer, or at least to think in a way that a computer can understand it. So that's the major trick here. So there are actually old videos in German as well. I don't think that they are needed unless if somebody's in the room who insists that he or she doesn't want to watch my videos in English. We do have old videos in German as well. Yeah, they cover most of the stuff. So the interesting thing here, So the way we do it here is slightly different than most programming for dummies books or so that you will find, or the way, like if you have, I mean, we're in Munich, so all of you have cool computer science friends, and when you tell them what we do here, they might look funny, because we approach the whole thing not in a very traditional how computer science people learn programming, okay? Because we will ignore a lot of concepts that are fundamental for programming, but I think nobody should care much about it, because all we want to do is write some lines of code to solve problems. And so we will not talk about like object-oriented programming or all this shit that all these people who learn Java and whatever and computer science, they spend lots of time with. A car is a thing with 4 wheels, and the bike is 2 wheels, so let's make objects out of it. I never understand how you get from this talking about cars and bicycles to them programming, but yeah, let's ignore it. So my approach is we try to be capable of something rather quickly, and then discuss the details later. So I want you to be capable of doing something, even if you only understand 90% or 80% of what we're actually doing. So yeah, that's okay. So again, the content or the semester is like in the beginning. Again, we spent like 2 or 3 weeks. I mean, there is a term, especially it's a little bit a term from the I don't know how do we call the previous decade? Is there already a name? From the 10 years or something? From the tenors? I don't know. I don't know. But yeah, but like 10 years ago, there was like a term big that was computational thinking. That's a little bit it's a bit old school in the meantime, because with ChatGPT and all these things, we realized that that the actual programming maybe is less important than originally many people were thinking. But the idea is that we'll cover from how can we, again, and I like the word, I know it's a German word and nobody outside of Germany says the word, but I will say it every 5 minutes, operationalization. Okay, so, and in German it sounds much better, Operationalisierung. Yeah? So how do we operationalize a problem in sub-problems, in sub-sub-problems, until we get to a point where we then can convert it into program lines. Yeah, that is the idea of computational thinking. Then of course we'll start with right away with some programming basics, so we can do some easy things, and this will have a lot to do with like string manipulations or text, basically, because it turns out social scientists, or yeah, I guess half of you people are some like management technology, and then we have always a consumer science corner somewhere, and then some random other things. But when you actually start to do research, it is often related to two things. It is related to some form of data that comes from the web. So you want to maybe download some things. And so what we will do here is we will download stuff from the internet and we will process the data. And often when we talk about processing and manipulating and doing things, it is often related to text. So we have texts, we have newspaper articles, we have something, we have protocols of some, I don't know, the parliament. And we want to look for certain things, we want to count words, we want to do some stuff. And so this is kind of the things that we'll cover here. And every time we do this, we need to like also process files, right? We download something, we store it on our computer, we analyze something, and at the end we maybe count the most important 100 words and how they change over time or whatsoever. And then we have a result, and then we want to export it in a way that maybe in SPSS or in R we can load it and make a pretty graph, okay? And so the number one problem for social scientists or for non-engineers in becoming good researchers is that they normally lack this preparation part of their data, okay? So many business school students are very good with numbers. So once their data is in a table that they can load into SPSS, Stata, R, or whatever, they are excellent because they know how to press the buttons and do regressions. But most of them fail because they cannot get the data into this format. So you can also see what we do here is also a little bit this pre-processing part, in order then you can actually do something with it. That's another aspect of what we want to do here. We will most likely not work with Twitter data because you maybe have, so in the past, it was very easy to access Twitter data. So there was like an API, and we all like could sign up and collect Twitter data in real time and do blah, 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 make fun. And there was always an exercise where people then wrote Twitter bots, and we had like an exhibition of like which Twitter bot can collect the most followers because of some weird behavior. That's not possible anymore because Twitter radically cut when Elon Musk took over, they cut all the access points for science and education. So there's most likely not possible, but maybe we'll find some other fun things to do. And in the last part, we will have different topics that are mostly related to like specific forms of analysis, specific forms of data. For example, maybe some of you want to do network analysis or something. And the great thing with or other data analysis stuff And the great thing with Python, which we will learn, I will talk about this in a second, is it's a programming language that is so widely used that everything you want to do has code and a package in it. So that's the number one advantage. So if you have some, I don't know, if you do research with an eye tracking device, there is most likely a package that then can directly analyze this eye tracking data or something. So that because there's something for everything. So yes, I will upload the videos on YouTube. So we'll have some playlists with topics. We will have the videos available, and as I said, I will most likely upload them in like patches, like a couple of them, so you can get into the flow. We'll have the meeting here Tuesday 11:30 in person for those who are interested, and we will do it in the way I pretty much talk from 11:30 to 1. Of course, you can ask questions and interrupt me. But at 1, I will run away, and then Anna Hitt, a PhD student of mine, will show up and will be more interactive with you in a sense of if there are problems or like if we're setting everything up, playing around, or she will do additional exercises with you in order to have some, to have more practice. That will be another info video in a week or two, but there will be some time before we start. The grading of the class is based on, I think there is a separate thing. So we will have an online platform for exercise submissions. So you will code something. There will be a video in a couple of days online, but you will basically register. That was not the thing. I was actually hoping for a. Nope, it's all on this one slide. Okay, sorry, I thought there is a separate slide for the platform, but there will be a separate video. So there will be a website that's called like, I don't know what, dot something, and dot projects dot Bayern. Haha, it's not a fun. We have the domain, and so there will be 4 exercises, and the exercises say do something, basically write some code, and then you can upload when you're done. You submit your code, and you get feedback right away. So the system tests your code automatically, and there are like 20 test cases, and when it fails at a test case, it tells you why it failed, and then you can fix your code if you want and resubmit. And so you can submit as long as you want. For example, until you have all the points, that's fine. But this getting an error message and fixing it is at least 50%, if not more, of coding. Okay, so this is what you will have in real life as well. So if I code almost every time I do work because that's the way I function. Some people say because I'm lazy and before I click something 5 times, I write some code. But yeah, every time, I'm coding now for my entire life almost, but every time I code, I write 5 lines of code, I press 5 in my thing is for start, and then I spend the next 5 times pressing or fixing the errors that I wrote in these 5 lines. Okay, so that's totally normal. Which brings me also to an important point when learning programming. That is, it is very different to everything else that you have done so far. Okay, so when you learn introduction to something, you often have a book with 400 pages. Okay, and you need to read the book, and if you know enough of everything, you might get a good grade. Yeah. Here, you learn by spending 5 hours on 10 lines of code. Okay, so often the result you can code something in 5, 10, or 20 lines, And once it is there, it looks completely obvious, but it's possible that it costs you 5 hours. Okay? And it is very frustrating half of the time. But that's the way you learn programming. Huh? And so it is very easy to get a good grade here without doing anything. Okay? You just have a friend who does the stuff, and you copy it, and you most likely will have all points. That's possible. And to be open with this, I know it's always dangerous to say something like this on video, but I don't really care. Okay, because it's not an obligatory class, so I'm not here to kick you out of some program. The class is kind of I don't want to sound like too arrogant, but it's kind of an offer for you to learn something, and so that's the interaction that's here, yeah, you'll see. But and that's why it has here so I would suggest, if you really want to learn to code, and a lot of people have learned coding in the last couple of years, and actually some people even, I have a couple of students who did this class in their bachelor, and then after, I don't know, did something else, and then started to study computer science as a secondary master or secondary bachelor, because they got into it. But I'm not expecting this from you. But I can tell you that if you are capable of coding, you are the one person in 10 or 20 applications for your job in consulting or whatever who is able to do this. And it's important to realize also that your future job will not require you to code, but you have a big advantage if you can speak with people who do the coding. Okay, so that's the number one thing. Especially if you're in some business school here, your job will not be to code something. Maybe you do it because you fix some problem quickly, but your number one challenge in your job will be that there are a lot of these nerds running around and nobody can talk with them. And so that's a little bit the way into this world. And so, which means I think it makes sense, especially in the beginning when you don't have other stuff to do, just get emotionally into the state of wasting an evening or two every week on coding random things. Yeah, you can do other things while you do this. You can drink a lot of alcohol, that's fine. I think it's sometimes helpful. You can watch some show or whatever, and you do some coding. That's fine. So it's really mostly practice, and to get into it. Good. Yes, I think you are here. Everybody who is here is registered. It makes a lot of sense to register because that's the way we interact with each other. So if something, I don't know, if I'm not here, for example, so I would send you an email. And of course I can only, because we don't have a Moodle, because I think Moodle is stupid. Yeah, I don't know. But Moodle is also like, Moodle is only working if you are registered, so it doesn't really make a difference. Okay. Right, which brings me to the question, how will I share the slides? I don't know. I'll figure it out. Maybe we have a Moodle. But you'll get the slides. Don't worry. Don't worry. Yeah, in general, I know most of you guys are German. I hope not. But I'm not, because I'm not German. So you can prepare yourself to write in your student feedback, Mr. Pfeffer is too late, he makes funny jokes, he's not prepared. That's fine with me. But yeah, that's the side effect of listening to non-Germans. So what I wanted to say is relax. Okay, we'll make it. Nobody will fail the class who has any wish to succeed, and everybody will get a good grade who tries to participate. So all good. Yeah, it's not some crazy shit where bad things happen. Okay, and if bad things happen, I will have a lot of fun with it. So we'll figure it out. Good. Important, but I think you're old enough in your study programs, you know that you need to separately register for the exam. I think you guys know this. Okay. There's this whole question of so if this class is not, So you need to know how to get this class into your curriculum, okay? So I have no fucking clue. So the class is listed in a lot of master programs, so that it counts there as an elective or something. If it is not, make sure to talk with your office, your student affairs office, and make sure you know how to get the class into your transcript to the place where you need it. If you are not from TUM, sometimes people are here who are from LMU or so. Again, I have no clue how to grade you. So, but most likely there is a form in your student office for participating at external activities. Just get it. I sign everything that you give me, but I don't know about it. So I don't know how to grade somebody from LMU. Yeah, so the stay on top of things, or not on top, but at least be part of things. So it's important to do something on a regular basis, because if you don't do something for 4 weeks and you look at the slides, you will think, oh, not a lot happened, because it is, again, it's a lot of in the details, and it's a lot in the practicing. And I know you guys are now the next generation of myself. So are you alpha? What is it called? What's the generation after something? Are you millennials, or what's the next thing? Huh? Gen Z, and then is the alpha, I think. But you're too old for alpha, right? Alpha is the teenagers now, right? I don't know. I just heard something the other day that we are running out of letters, and so they propose to call them alpha now, which I think is a little bit. We should not call anybody alpha, because I think this goes to their brains. But anyway, no. But what I have learned is there are a lot of people who do not read their emails. I don't know how this works, because I only communicate via email. So I will send you an email every now and then. For example, because I don't want to go to class or so, because I have a good excuse, or something else, or something is online, or so then I send you an email. So make sure to look into your emails every now and then. Yes, let's stay flexible. We'll figure it out. We'll learn something. If you have some interesting aspects, interesting topics, or so, let's talk about this. I think we have enough space to be also flexible in content. Yeah, and let's stay relaxed, because especially I know that yes, there are always a lot of always students who are not used to, how to say it, to be frustrated. So if you're used to having very good grades all the time, stay relaxed, even if your shitty 5 lines of code don't work after 5 hours. Okay, you'll figure it out. It's okay. Good. So these are the inputs at this point from the organizational perspective. I have some slides with me as well, so I'll also, I don't know, waste another half an hour of talking about content. But is there any question at this point? Any comments?
Yes, when will the homeworks come out?
The homeworks, I don't know. I guess like I think we have 4. And we'll start with a little bit talking around without coding. I'll say the first one will most likely be like mid-March or so, and then every 2 weeks or so, every 2 to 3, something like this. So mid-March, and then after, like this, then a week, something like this. Yeah, and then you have always a week to finish the stuff, and then there's a week nothing, and then the next comes out, something like this. Sorry? I think so. What's now? Yeah, I think we need we probably need like 4 weeks or so to get things a little bit moving, and then we start with the first exercise. Yeah, something like this. Yeah. There will be no final exam. Yes, there will be no final exam. There will be no presentation. There will be nothing to read. I might suggest sometimes there is something to read up. it often makes sense to look for stuff by yourself because guess what? YouTube is full of people who are way more interested in teaching than I am. And so there is a lot of good stuff on YouTube to learn programming and everything, and you will find stuff online. But they might be the problem that I find often also with books and stuff is that there is kind of many YouTubers and also books have the need to introduce a lot of concepts before they start. And this I find this is not very helpful because it's like almost a theoretical because I think if you learn coding in 2024, you really don't need to know what binary numbers are. Yeah, so and this is just a simple example. There is no need in knowing a lot of this computational introduction to this introduction to computer science from the 80s. Okay, so I mean, what you maybe had in your high school thing, right, where you learn some things and then you and or and something. That's okay, but we will see some of those things anyway when we code, and the things we don't see, we don't need. So it's yeah. But again, if you don't understand, yes, that's the other thing. So first of all, if stuff doesn't work, you will see. So the internet was mostly written by nerds. Okay. So I know you guys only spend time on reading the, I don't know, business news and stuff, but there is a whole world of millions and millions of pages of people who code or learn to code. And the other thing is Python, the programming language that we learn, I will show you in a second, is also used by most people in the meantime. So this is the number one programming language that people use in all areas. So any problem that you Google with the word Python, you will find a solution, and you will find hundreds of solutions. Yeah? And so most likely especially at the beginning when we have these sample exercises of how to solve a problem or so, you will also find all these problems, of course, online because they have been solved millions of times, and also ChatGPT will know them. And so it is in your discretion what kind of help you take and what doesn't. So you will most likely find your entire code that you need for an exercise on YouTube or on online, or if you ask ChatGPT, it will give you the code because it's very very standard things. But sometimes it makes sense to look online, to watch a video of somebody or something. Is there open actually? Oof. Ha. Should we get some fresh air? Makes sense, right? Can it have your... I guess this violates some fire code or something. Works. Any other question?
Does each homework count 25% to our grade?
I have no clue. I don't remember. I think so. Maybe the first one is less. I'll double check. But it will be online. You will see it. It's I think last year we had something I think it was you can reach 200 points, and I think each one was 50. Maybe one was 40 and the other 60, but I think it was about the same. I think it was 4 times 50. Okay. Anything else? If not, we'll start with some slides here. Let me again. You see, I'm still a little bit unsure whether this whole recording works. We'll see. Okay. So no more administrative questions? Okay. Um, let's talk a little bit why and how we approach the problem. So first of all, these are like the, I mean, this is super old. This is super old article from maybe you saw similar things, but basically what this is like one of the, I still have it in here because it was it was in 2013, one of these first data journalism exercises. And in back then they found this large, like these leaks. You probably have heard about these like tags offshore, like some random island somewhere, and then somebody steals a DVD full of information about I don't know, 12,000 rich German assholes who park their money there and don't pay taxes or these kind of things. Okay, and so that was one of the founding stories of data journalism, because then they had like they had this thing and a couple of newspapers working together, and but the reality was like there were like in these documents there were 130,000 people from 170 countries. They had like what does it say, 2.5 documents, pages. I think the second one should be pages. There were like millions of documents and pages, and then they had like databases with 2,000 to 3,000 like offshore companies who were used to funnel the money and these kind of things. And here's like and it's clear, and of course 10 years later it's very clear that nobody can actually read this stuff, right? So you need some ways to analyze or to handle the data, and so they started to work with like also with special software to annotate things, to automatically search for things, which today is standard. Another thing is another aspect is that once you look a little bit, the world is full of data, and if you figure out how to use the data, many things. Here, this is just like I don't know, some screenshot of some TUM Twitter thing. We have like thousands documents of plenary protocols of the parliaments of the countries of the European Union and these kind of things. So so when you can access this data, you will right away see that this might be helpful even for your study. Like, I don't know if you have thought about planning your bachelor or master thesis. Guess what? It will be much more fun if you have data and if you can analyze something. So, and the moment you have the ability to download something, or to even, I don't know, maybe you want to do a little project about the Donald Trump stock experience, and you don't find the right collection of the stock market price because you want it on a 5-minute granularity or something. Well, you now in 4 or 5 weeks you're capable of programming code that monitors some random website and accesses it every 5 minutes automatically and downloads values, like for example stock values. So the moment you're capable of doing these things, it will automatically enrich what you do in your profession or your life or your studies. And why I have it here live, and this is a little bit, of course, also a little bit. I mean, you're now sitting here for 40 minutes, and I'm already talking about the rest of your life. But I think being able to code, and especially this process of operationalizing a problem, is helpful even if you're not coding, because I think it completely dominates the way I think about any problem in the world, because the way I'm programming is every problem is a combination of subproblems. Every subproblem is a combination of subproblems, and then you solve them one by one, and then it's solved. But in order to see these subproblems, yeah, you need to think this particular way. Again, practice, practice, practice. So it means a lot of trying to code and failing. So I mentioned the programming languages before. We can close now before somebody dies here. So there are, when you Google or when you look at Wikipedia, there are hundreds of programming languages there are tens of very famous programming languages that everybody knows by name, or that have been very important in the development of computers and computer science. There are hundreds of programming languages that are actually used, and there are thousands and thousands of programming languages that are very specific for very specific things, and that basically nobody uses. And every other PhD student in software engineering, as part of his thesis, develops his own programming language to fix a certain thing and certain problem in the world. So we do Python, Python, but also in German we say Python. Why? Because it's very widespread, so everybody uses this in the meantime. This was different like 5 years ago, 10 years ago. But it's really dominating the programming market in the meantime, because it is very easy to get started. So we can do something within minutes, and it is scalable in all directions. So you start with it, and if you start to program now, and in 5 years you are responsible for optimizing the cooling system in a nuclear plant. There's a good chance that you can still work with Python, because all the fancy math, all the fancy data science, every machine learning problem in the world can be solved in Python. So like, I don't know, like training a support vector machine in deciding whether a picture is, or I don't know, some deep learning algorithm about is this the number 4 or the number 5. You can Google this problem and you will find a YouTube video where a guy shows you how in 10 or 20 lines of code write a deep learning AI something algorithm in Python, because there are all these thousands and thousands of packages. We will talk about packages later, but it's basically, you never start, if you have a more complex problem, you never start at scratch and write everything, but you just load other people's code and then you work with this. And so most of the problems, of the bigger problems, are very limited to a couple of lines of code. So for example, collecting Twitter data was like 5 lines of code. Okay. Again, easy machine learning applications are 10 lines of code, and this code is really like I don't know, load data, subset data, training data is, train data, predict. That this is basically, and the lines are really named this way. So this is it's a very straightforward way of handling things. And this is why we use Python, because from text analysis to machine learning to network analysis to a Fourier transformation, or to whatever you want to do in your life, you will find code here and help. And help in the internet, because everybody uses this stuff. Okay, so what is programming? And there is this Wikipedia entry about computational thinking. So from there I stole some stuff. But it is the and you don't need to write anything down, because of course I'm sharing the slides. So computational thinking is defined as the thought process involved in formulating a problem and expressing its solutions in such a way that the computer can effectively carry it out. Okay? And the funny thing is here, the computer can be a human or a machine. It just means you automate a problem. You basically split up a problem in a way that you can delegate it to somebody who has no clue about the problem, but who is capable of doing simple things. So, and if you optimize if your task is to organize a party for 100 people, it is clear you can operationalize the problem on several levels, right? If you have a lot of money, you can just outsource the entire problem and hire somebody who organizes the party for you. Or you have 3 friends who want to help, and then one does the invitation, one looks for the music, one does the location, and one buys the beer. Yeah? And then these problems are separated. But what does it mean to buy beer, right? So you need to estimate the number of people that come. Beer. Okay, where do we buy the beer? So you can, if you have maybe not, it's possible that this guy the beer guy thinks that he needs to outsource his problem to 2 or 3 people. So he could actually have one friend who goes to the location and looks for how many people fit in there, and then another one goes to talks with somebody who organized similar events, and then he comes up with the number, and then he has another friend who buys the beer. Okay, how do you buy 1,000 bottles of beer? You need a car, right? So somebody needs a car. So depending where in this chain you are, it is possible that at the end of the chain, we have a person with no education who doesn't know anything, but who can drive a truck and pick up beer. And this is basically this computational thinking process, is this operationalizing a problem to the degree where a human, or in our case, of course, a machine, with simple capability can solve the process. Now a couple of terms. So what I now mentioned in a couple of examples are these 3 steps of like figuring out how to do it. So we need, first of all, we need to abstract the problem. Yeah? Because it turns out when we talk about the problem in real life between people, a lot of the stuff that we're talking about is not relevant for a problem. Okay, so we need to, and also the abstraction also means that a solution doesn't just fit for one. Because you guys always, is this actually? I think we would be able to turn on here things, isn't it? Oh, yeah, it's on here. That's not on. Was this sharp? No. Interesting. Okay. That's why you're sitting here. That's okay. They have a monitor for themselves. Anyway, but it turns out that a lot of problems that we describe are not only there to solve a specific problem, but can be generalized, right? Can be abstract from the instance of a problem to a more generic problem. Then it's about automation. So how can we automate something? And of course, how can we then execute and evaluate whether this works and maybe optimize it? So this decomposing or factoring, these are just some computer science terms, but what we're actually talking about is what I just mentioned a couple of times. We have a complex problem, and these complex problems we need to split up in a lot of parts that are rather simple, because the programming language is mostly rather simple. So we do something, and then we can solve it, but we need to decompose the complex problem. So, and the algorithm is actually to finish this definition round here. So an algorithm is a detailed and explicit prescription for solving the problem step by step. So an algorithm is nothing else than like the cooking recipe. Okay, so first, second, third, do this, do this, do this. That's the algorithm. So when we talk about algorithmic something, it means the steps that are necessary to do something, to solve a problem. And the algorithm is executed in the individual steps. So it is actually step by step. So nothing, I mean later maybe, but normally nothing happens somehow in parallel or in random order. It is always step A, step B, step C. It's never step C, B, A. It's always A, B, C. Each step is very simple. It's a very simple basic action, and it's very clear for every step what needs to be done. Yeah. So you will see very soon how this looks like. And so again, to summarize this thought, so that is also on some slide. We have a problem. What are the parts of the problem? What is smaller, and what can we program? And the interesting thing is here, and I will show you this in a second, what we first will learn in this whole computational thinking thing is that it's often the hardest, or one of the harder parts is to figure out what the problem is. Because when we want to implement something, we really need to know what the problem is. Not just we think about what the problem is, but we really need to answer every sub-question, okay? And what I wanted to do today is, and this will also be in some videos, but just to show you the process is, do we have do we have Marcus? Oh, here, thanks. A whiteboard, okay. So the remaining question is, do they work? Excellent. Nope. Good. It's a very important function to help the next lecturer by throwing things away. So, so what we want to do now is we want to decide, and this is one of the standard. I hate this thing. Okay. So we have a question that is, is the year X a leap year? You know what a leap year is? Schaltjahr. So a leap year is when the year does not have 365 days, but 366 days. Okay, that's a leap year. And we have the leap day, the 29th of February. Okay. So is any given year, is this a leap year or not? Okay. So is 2024 a leap year? Let's start with, and this is also important, when operationalizing a problem, it's okay to start with concrete examples, okay? But be aware that this is one example and later you want to generalize it. Okay? So let's to understand the problem, it's okay to start with a, okay. So is 2024 a leap year? Yes. So why do we know this? Any ideas? Yeah? We can divide it by 4, okay? So we say if, let's stick with X, divided by 4, if this is, and I put in here one thing, I put here two equal signs. Okay, we'll talk about this later. But if I want to say equals, if I want to compare things, I put in here 2, because if I just add 1, it's like it's an assignment. So if I say x is 4, then x has the value 4. So we use 1 equal sign to assign something, and 2 if we want to compare something. So this is, so x is 4 means there's a question, yes, no, and this is a 4, so x becomes 4. Okay, good. So okay, so you say if x divided by 4 has that's not correct, it's the rest, right? Okay, so you know a fancy term for rest? Huh? You I saw your big O. What? Modulo, correct. Have you heard the term? Modulo. I'm not sure how to pronounce it in English, but it is often written in modulo, something like this. Right? I have no freaking clue. So if x, so it's like this, right? If x modulo 4 equals 0, so that means the rest. Yeah. And I'll add some notation here. We can there is this percentage sign that actually in Python means modulo, but we don't need to know this by now. So x modulo 4 is 0, which means I divide x by 4, then I have a result, and I have a rest. Okay, so I have a comma thing. So what's behind the comma? So if I have 5 modulo 4, the result is 1. Yeah. 7 modulo 4 is 3. 13 modulo 4 is 1. Okay, so it's always the rest of the division. It's clear? Okay. So you say if this is, so that's the question here. So we have an equals, so we have a yes or no, okay? So if yes, let's maybe even, let's do it later in pretty. So if it's yes and if it's no, okay? What if it's yes? You said that's a leap year, correct? Leap year. And here, nope. What about the year 2100? Is the year 2100 a leap year? Are you sure? Google, is the year 2100 a leap year? Google exactly this question. What does Google say?
It is divisible by 100 and not by 400.
So is 2100 a leap year? No. Shit. Okay? So in the process of defining the problem, we realize we have no freaking clue about the problem definition. Because it turns out a leap year, so if we can divide it by 4, it is only a leap year if we cannot divide it by 100. Okay? So why is this the case? Because it turns out why do we have a leap year? You know why do we have a leap year? So why do we need the shit? So what's the real world problem? Why did they come up with a leap year in 1600 something? I don't really know the number. Yeah? Correct. So there is the sun, whoop, and there is the earth, and we move around, and this moving around takes actually 365 comma something days. Okay? So it takes 365 days and about 6 hours. So every 4 years we have another day. Okay? Somewhere 500 years ago they figured this out, that the freaking calendars don't work. Huh? So they introduced this leap day. So it's about 4 hours. So that's why we have the leap year. And guess what? A couple hundred years later, they figured out it's the 4 hours correction is too much. Huh? So it actually takes only 3.9 something hours. Okay? This means that with the leap years, we give in too much. Okay? So we give in too many days with the stupid leap years. So, oh, sorry, it's wrong. Wrong thinking. It's 4 points, right? That was a wrong thinking now. Right, sorry. It's 4 point something. So it's 4 point, I think it's 0 something. There are some numbers, but there is a number, okay? Let's call it 5, I don't know. So every 4 years we have the 24 hours, but we have a couple minutes too many, okay? And so what they decided on is that every 100 years we don't have a leap year, okay? So we take these, because these 5 minutes or something accumulate over 100 years to be an extra day that we then take out again, okay? And so it turns out that if this divided by 4 is 0, yes, then we need another question that says, can I divide this by 100? And if yes, so much junk standing around here, holy moly. And if yes, it is not a leap year. And only if this is no, it is a leap year. Okay? So one last question. Was the year 2000 a leap year? So 2100 was not. Was the year 2000 a leap year? Shit. Why? Exactly. Because these 5 minutes accumulating over 100 years that we take out, we took out too much again. So every 400 years, we need to again count, basically count in the other direction and say if a year is possible to divide it by 400, it is still a leap year. Okay? So how do we do this now? So we can divide it by 100, yes, but then we have another question that says, can we divide it, and I make this funny symbol here, can we divide it by 400? Okay? And if we can divide it by 400, so if we divide it by 100, yes, it is here. If we can also divide it by 400, it is a leap year. But if we cannot divide it by 400, then it is not a leap year, even though we can divide it by 100. Okay? And so that's what we do in programming. So we try to solve something, we realize that we have no clue what we actually want to solve, but we need to really know it everything in detail, because we need to answer all these questions in order to decide whether a year is a leap year or not. That's I can make a copy, I can make a photo, but it's not, I think it's nicer in some slides, I think yeah. And also I changed the notation 3 times, so it's not a very good thing that I did here. Is it clear? So, and once we have this, we will have the 4 or 5 lines of code to decide whether something is a leap year or not. Because now we can like if then, else, if then. That's it, okay? So we now need like 3 different words in programming, like the if then and else, and then we can answer this question whether this is a leap year or not. But in order to get there, in order to get to this programming part, we needed the algorithm, okay? And the algorithm often requires something like this. So next week, we'll talk more about this process of figuring out the problem and figuring out how to operationalize the problem. And you now have some nerd information, because you know how leap years work. Because as you can see, even if there are like, I don't know, 60 people in the room, nobody really knows. No, you know now. Which most likely will be the 200,000 euro question in your next Who Wants to Be a Millionaire TV show. Any questions, any comments? I think we can leave it here. I think there's also no need to, I will tell Anna, there's really no need this week, I think, to have any tutorial or exercise activity, because we haven't started doing anything. So we'll start next week when we do more things to have then the additional time with the PhD student, talk about things. All good? No, I will send an email hopefully today or tomorrow with uploading this video and sharing the link and maybe sharing first slides, and then yeah, we go from there.